Okay, so you may remember the pressure, specific volume, temperature, surface for water from chemistry. And so this is a surface, a three-dimensional surface that shows you pressure, specific volume, and temperature, and then the states in here, when it's solid, when it's liquid, when it's vapor, when it's a liquid vapor, when it's a solid vapor, what the critical point is. There's a lot of things that we're going to be looking at with this PVT surface. Now, there are, two-phase surfaces, two-phase regions here, not just single phase. So we have liquid vapor, solid vapor, and solid liquid. We are mainly going to be concerned with the liquid vapor region of our problems. Now, this dome here that you can see is a very important concept in thermodynamics. We call this the vapor dome. Okay, it's where inside that dome the liquid and vapor reside. So on one side of the dome you're going to have all liquid, on one side of the dome you're going to have all vapor, and then in the middle there you're going to have liquid vapor. Now, where the liquid changes to a liquid vapor, so this line right here where the liquid changes to its vapor is called a saturation state. Okay, so the liquid basically gets to a certain point where it's completely saturated. It's as liquidy as it can be, and then it tips over. It's a tipping point until it becomes a liquid vapor. On the other side, this vapor, you are going to go through a place where there's another tipping point, and it's going to be represented by your saturated vapor line. Okay, we'll talk more about that here in a second. Where these two lines meet, the saturated liquid line meets the saturated vapor, is called the critical point. And it is the maximum temperature at which liquid and vapor phases can coexist in equilibrium. So we're going to have a critical temperature and a critical pressure. And you might remember just from looking at table A1 in our chart, we have for every substance, we have what that critical temperature and critical pressure is. So we can project this onto in three ways. Temperature pressure projection is what we have here, and we call that a phase diagram. We are not going to use this phase diagram very often. You will use this in your chemical engineering classes. You'll use it probably in your industrial engineering classes where you're dealing about machining and manufacturing. You deal it with chemistry, but we're not going to deal with it much in here. But I do want to show you that we can still show the saturation temperature here. So if we look at a temperature, at some temperature, we can find the corresponding saturation pressure where this phase change occurs. Okay, so I want you to understand that this is still connected with things that you've learned about before. I want you to not say it's nothing new, but we're just having a different view. You've probably used this diagram many times, but as we spin it to look at a PV, a pressure-specific volume, or a TV, a temperature-specific volume projection, that is going to be more useful to us in thermodynamics. Okay. Now, I'm going to show you these PV diagrams, and I'm going to show you a TV diagram. So this first is going to be a PV diagram, and you can see pressure, specific volume here. You see the vapor dome, you see the critical point, and then you're going to see lines of constant temperature that are going to come down. They go down and to the right, down and to the right. You would also see a TV diagram, temperature specific volume diagram, where you have a vapor dome and your lines of constant pressure are going to go up and to the left. Now you are not going to have to remember these exactly. These pictures I have here on the screen are the exact representations of the PVT surface, okay, the projections here. What we are going to draw for ourselves, for our reference, are sketches of these. So let's go to the one notebook and find out how I'm going to draw this. And let me see here. I had a cat that was wanting to get out of here. I think. Kitty, kitty. Okay, no. He's over giving himself a bath underneath another table. Okay, so let's talk about this. Let's talk about the projections of the PVT surface. Let's talk about how we are going to draw it. So let's draw ourselves a PV diagram. Here's what I want you to do. I want you to draw a vapor dome. Is that the same vapor dome that we just saw? It doesn't look exactly like it, but it is a vapor dome. It is a vapor dome. Okay. I want us to be able to label things on this diagram. This point right here, the very top of that, is the critical point. Okay. Now, remember, and it's very important, what lines of constant temperature look like. Lines of constant temperature come down. As they go across the vapor dome, it's a straight line, and then they go down again. So this is a line that temperature is equal to constant. Now it's some temperature. I don't know what temperature it is, but it's some temperature. We can have lots of lines that go like this. They all go like this. All right, now, another thing. This side of the vapor dome, this side here, is our saturation line, and then we'll draw the other side over here. This is another saturation line. Okay, all this whole line. Now, what do we have? Over on this side of the critical point, we're going to have liquids. And over on the other side of the critical point, we are going to have vapors. And in between this, in the vapor dome, we're going to have liquid vapors inside of it. Okay, so you need to know those regions. Liquid region, the vapor region, the liquid vapor region. You need to know about the constant temperature lines. You need to know that this line here, this entirety of this yellow, the entirety of this yellow is going to be the saturated liquid line, and the entirety of this green is going to be the saturated vapor line. You need to be able to draw these over and over and over again and know exactly what's going on here. Now, we also need to be able to draw a TV diagram. So let's draw that. The TV diagram is going to have a vapor dome that looks very similar to what we drew before. Again, these are just drawings. These are helpful drawings for me. They are not necessarily perfect. I'm not taking out and mapping out some perfect line. No, they're just a representative diagram. I know, and I put this in red on the last one, so I'll put this in red here if I can. Oh, I just knew I'd do that. This here is our critical point. Okay? Everything over here is a liquid. Everything over here is a vapor. And in between we have a liquid vapor. Okay? Our lines are the same. This is going to be our saturated liquid, saturated vapor, and this is going to be our saturated liquid. Okay? This is going to be our saturated liquid, and this is going to be our saturated vapor. Very similar to a PV diagram. In fact, everything I put here is the same. But what's going to be different is that we're going to have lines of constant pressure that are going to go up like this. This is pressure is equal to constant. It's the opposite direction of a TV diagram. Okay? And so you're going to have many lines of constant pressure that you're going to be having here. Again, you need to know how to draw a TV diagram. Now, I want to show you, we're going to use these diagrams so much this semester, but I want to show you through a PowerPoint here how they can be nicely used. Okay, when we're going to be describing a phase change, and I'll do that here after the break.